Hello, I'm Brandon Reynante, a doctoral student at Stanford University and a consultant for the Engineering for One Planet initiative. The EOP initiative is working to transform engineering education to enable all future engineers to be equipped with fundamental principles of sustainability. A challenge to this vision is that engineering education is one of the most resistant to change areas of higher education, and sustainability has been historically marginalized within engineering due to a variety of ideological and institutional factors. In this video, I will share findings and suggestions from a literature review I conducted to help support the EOP Scaling for Impact workshop. The literature review was guided by the following questions. The literature review process consisted of two phases. In phase one, I searched databases most salient to engineering education using combinations of relevant keywords. In phase two, I reviewed all resources for inclusion based on three criteria: impactfulness, typically assessed via citation count, relevance to the topic, and complementarity with the other resources. At the conclusion of the search and assessment process, a total of 70 resources were fully reviewed. Some relevant citations can be found at the bottom of the slides, and the full citations can be found in the literature review report. Here, I list some key stakeholders in engineering education and their power and interest regarding sustainability. Institutional level decision makers, such as university leadership and department heads, perhaps have the greatest capacity to influence sustainability integration because of the power they hold. They can influence change for the most people in the quickest and most systemic way. The literature review uncovered several approaches to how sustainability is currently being incorporated into the curriculum. The add-on or vertical approach involves creating a new standalone course and is by far the most common. The integrated or horizontal approach involves embedding sustainability into an existing course and is somewhat common. Another approach is to create a cross-disciplinary course with the non-engineering department. A rebuild approach involves creating a new program, and this is quite rare. The figure shown is from a 2009 study of over 400 faculty and department heads showing the number of sustainability-related courses in their departments and programs, along with their percentage of sustainable engineering, or SE, content. The add-on courses devote a larger proportion to SE because they were designed specifically with SE in mind without having to directly consider other learning outcomes. The concern is around depth as opposed to breadth. The horizontal approach includes less SE content than the vertical approach because they typically need to consider numerous learning outcomes. The concern is around breadth rather than depth. Embedding sustainability broadly within regular courses, the horizontal integration, is better than vertical integration for reaching more students and for encouraging students to view sustainability in a systemic and holistic manner. The combination of horizontal and vertical approaches is the best way to assure breadth and depth of coverage. However, there have been few efforts to thoroughly embed sustainability within the curricula in a holistic manner. An example program where sustainability has been integrated throughout the undergraduate curriculum is the University of Texas, Arlington. This effort was led by a faculty team from the civil, industrial, and mechanical engineering departments. The National Science Foundation provided 2 years of funding, and corporations provided internship opportunities. The team used an integrated or horizontal integration approach with several key features. They created 11 sustainability modules, each approximately 1 class period in duration. These were integrated into 17 traditional courses across all levels of matriculation, which ensured that all students would be exposed. Each module was designed to assess all 3 pillars of sustainability, but social aspects were often neglected. 8 of the modules used some kind of active learning component. Second, there were sustainability internships. Faculty created a survey to find suitable companies and then placed 6 students at 4 companies over 2 different summers. Finally, there was a multidisciplinary senior design project with a sustainability focus. To evaluate the program, the team defined 4 student learning objectives. 1, increased knowledge of sustainability concepts. 2, increased ability to analyze project components for sustainability. 3, improved ability to propose mitigation strategies for reducing negative impacts. And 4, ability to apply knowledge to real-world problems and projects. Learning objectives were evaluated using test scores and student surveys. Success was defined as 70% of students meeting the goal. The first two outcomes were only partially achieved, but the third and fourth outcome were achieved. One challenge was buy-in from instructors who were not part of the core faculty team leading the integration effort, but there was no mention of any attempt to resolve this issue. I now present case studies of systemic change processes at institutions where sustainability was integrated throughout the core curriculum. The institutions are Chalmers University of Technology in Sweden, the Delft University of Technology in the Netherlands, the Georgia Institute of Technology in the United States, Tecnológico de Monterrey in Mexico, Cambridge University in the United Kingdom, and the University of Technology Sydney in Australia. The cases represent diverse institutional, geographical, and socioeconomic contexts, as well as diverse integration approaches. I analyze the cases with respect to key dimensions of systemic change, including triggers, change processes, barriers, strategies, and success factors. There was not as much data on whether these models were sustained or expanded over time, although there is some evidence that this has been the case for TU Delft and Cambridge. Most cases involved internal recognition of the importance of sustainability by department or university leaders, which often led to incorporation of sustainability into mission and vision statements or institutional policies. Most cases also involve some sort of external trigger related to either national policies and laws, accreditation, or funding. For example, the Swedish accreditation agency pushed Chalmers to incorporate sustainability to satisfy a national law. Another insight is the potential for using external reforms as an opportunity for other changes, as in the Georgia Tech case. Here, the Board of Regents switched from a quarter to a semester basis and asked academic programs to consider other curricular changes. Curriculum renewal in engineering education can involve top-down and/or bottom-up processes. In top-down processes, administrators initiate change to integrate new content across program offerings, and most staff are involved. In bottom-up or ad hoc processes, individual faculty early adopters carry out changes within single and isolated courses, build support, and sometimes eventually gain formalization. In case studies, top-down processes and the rebuild approach were fastest, while bottom-up processes and the add-on approach were slower. In all cases except one, the change process began as part of a top-down, department-wide plan intended to be more holistic. A bottom-up approach places the onus on individual faculty champions who typically have little or no support from their institution, which seldom results in systemic change. However, solely utilizing a top-down approach seems to be insufficient, as all of the top-down cases required buy-in from most faculty, and the bottom-up case had at least some formal recognition and support from the administration. The case study institutions face numerous barriers to sustainability integration. Several mindsets and ideologies deeply embedded in engineering culture render sustainability as marginal or irrelevant to engineering. Regarding academic culture, sustainability requires a multi- and transdisciplinary approach that lies outside of traditional disciplinary boundaries. Also, integrating sustainability does not complement the rewards and recognition systems at most educational institutions. There are also organizational culture barriers. For example, various courses are owned by separate units, and there is limited funding. Thus, changes in curricula impose financial costs and can spark internal conflict regarding division of assets. Furthermore, anything new that draws resources and energy from traditional programs may potentially hurt rankings and will thus be disfavored. Regarding societal culture, sustainability might oppose the status quo in industry, which is driven by short-term profit. The curriculum is already rigidly packed with required technical courses. There are also barriers in terms of faculty attitudes and capacities. For example, lack of familiarity with and preparation to teach sustainability, as well as perceived threats to the integrity and ownership of course subject material. Finally, many students may resist dramatic curricular and pedagogical changes. Prior work on systemic change in engineering education has categorized strategies using the 4 categories of change strategies model. This model has a 2-axis grid framework. One axis is the aspect of the system to be changed, either individuals or environments and structures. The other axis is the intended outcome, either prescribed or emergent. The initial strategy used by Chalmers was diffusion. This is where innovations are created in one location and then adopted or adapted by others. This is one of the most widely assumed strategies in engineering education. However, it failed because many faculty without pre-existing interest in sustainability lacked motivation to make changes. At Delft and Cambridge, they initially used a teach the teacher strategy, but this faced resistance from faculty because it infringed on their sense of autonomy. Chalmers, Delft, and Cambridge eventually found success with the Ask the Teacher strategy, where faculty were invited to suggest how their own subdiscipline might contribute to sustainability, which sparked their interest and led them to adapt their courses. Georgia Tech, Monterey, and UTS succeeded with the organizational development strategy. This is where a leader develops a new vision, policies, and structures for aligning employee attitudes and behaviors. Policies included imperatives to integrate sustainability by a certain deadline, and structures included faculty working groups. However, this strategy was insufficient to enact widespread change at TU Delft, which suggests that institutional mandates may sometimes need to be accompanied by individual change strategies. Which strategy to use depends on the particular context, including type of change desired, available resources, and the power and position of the change agent. Use of multiple change strategies may increase the likelihood of success. Common success factors across the cases are provided here. Many of these align with findings from other studies of successful systemic curriculum renewal in engineering education. Despite massive efforts in recruitment and retention, engineering education is not significantly more diverse than a generation ago. While justice, equity, diversity, and inclusion was not explicitly mentioned in any of the example case studies, sustainability is a promising way to support JEDI. There is growing evidence that engineering focused on social sustainability could help attract and retain females and underrepresented minorities. Community-engaged learning, also known as service learning, has been called an ideal vehicle for both sustainability and inclusiveness in engineering. This approach involves working with a community partner to address a societal issue and then critically reflecting on one's learning. Community-engaged learning contexts have the opportunity to provide an environment that challenges traditional engineering cultures, values, and identities with its focus on societal impact. 2 well-known optional community-engaged learning activities in engineering that have significant overrepresentation of women are engineering projects in community service, or EPICS, and Engineers Without Borders. Studies have found 3 main reasons why women participate. First is to gain authentic engineering experience in a setting that is comfortable to them. Second is a desire to help others. And third is the team/community environment, which offers a social interaction and a support group. Current historical factors make the integration of sustainability into engineering education viable. A one-size-fits-all approach may not work given the uniqueness of different institutions, but here I provide several recommendations based on the various case studies of systemic change across diverse contexts. 1. Curricular reforms, for example, to meet accreditation criteria, crises, for example, of enrollment or funding, and market positioning, for example, rankings, provide an opportunity to enact other changes to the curriculum. One emerging market positioning opportunity is the new Carnegie classification, which ranks universities based on how well they contribute to social mobility. Since engineering promotes greater social mobility than other disciplines, an opportunity could be created by touting the promise of sustainability to attract and retain women and underrepresented minorities to engineering. 2, to facilitate deeper student understanding of sustainability, integrate it at multiple locations throughout the curriculum. This requires either an integrated or a rebuild approach to incorporating sustainability. An integrated approach involves embedding sustainability into several existing courses. A rebuild approach involves redesigning the entire curriculum. One barrier to integration is a perceived lack of space in the curriculum, but this is based on the faulty logic of the coverage model, which assumes greater coverage of content translates into greater student learning. If a standalone add-on course is the only option, design courses are perhaps the best location for sustainability. 3. Curricular change is generally faster, more coherent, and more holistic when the process is triggered at an institutional level, and slower when initiated by individual faculty. However, it is vital to establish a sense of responsibility for integration all over the institution. Change leaders should identify and support existing faculty sustainability champions. 4. The most appropriate and effective strategies will depend on the particular context, but in general, two strategies seem to be most effective, especially when used in combination with each other. The first strategy is organizational development, which falls into the category of enacting policy, and it aligns with a top-down change process. In this strategy, a change leader develops a new vision and structures for aligning stakeholder attitudes and behaviors. Promising structures include dedicated funding, faculty working groups, and a center that is in charge of all sustainability change processes. One promising policy reform is to reward faculty participation in sustainability efforts. The second strategy is faculty learning communities, which falls into the category of developing reflective teachers, and it aligns with a bottom-up change process. The teach the teacher strategy can trigger resistance from faculty because it may infringe on their sense of autonomy for their courses and their desire to protect the boundaries of their discipline. The ask the teacher method, also known as the individual interaction method, where faculty are invited to suggest how their own subdiscipline and courses might contribute to sustainability, has been much more successful. 5. Project-based learning and project-based service learning are the most effective teaching methods for both facilitating student learning about sustainability and for recruiting and retaining women and underrepresented minorities. Project-based learning and project-based service learning are also a promising public relations and fundraising tool, as administrators love to tout civic engagement and philanthropic donors are more likely to support initiatives with positive social impact. Lastly, I present some gaps and potential areas for future work. 1. What are current industry perspectives and practices regarding sustainability? Historically, there has been a general lack of concern or even conflict regarding sustainability within industry, along with concerns about the employability of sustainable engineers, who might oppose the status quo. 2. How might we effectively lobby powerful stakeholders? None of the cases explicitly mention this strategy. However, stakeholders such as ABET, the National Academy of Engineering, and the relevant professional body for each particular discipline could be powerful driving forces for integrating sustainability into the curriculum. And lastly, how might we intentionally design programs to attract women and underrepresented minorities? JEDI and engineering education has largely centered on women rather than other underrepresented minorities. Also, the community engaged learning programs are attracting a higher proportion of women unintentionally. This concludes the literature review video. Thank you for listening.